All right, welcome to sequences, part 1. First of all, let's look at what a sequence is. Now, a sequence is basically a list of numbers separated by a comma. For example, how about this sequence that you're probably pretty familiar with? And so on. By the way, dot, dot, dot means and so on. So here's a very simple, basic sequence, 1, 2, 3. These little numbers here, they are referred to as the terms of the sequence. So those are the terms, and typically we identify the first term, even though it's kind of like term 1, it's very common to use the letter A for term 1. And then we have term 2 and term 3 and so on. Okay, so that's kind of the basics of a sequence. And we're specifically going to look at certain types of sequences called arithmetic sequences. So that's the focus for today. So arithmetic sequences, what are they? Well, the one that I wrote there is an arithmetic sequence, this guy here. And the reason it's an arithmetic sequence is because if we look how we go from one term to the next term, we keep adding 1 each time. So we go, okay, we seem to be adding the same amount over and over. So we would predict the next term in the sequence, well, if we added 1, I think it would be a 4. And then we would add 1, I think it would be a 5. And we just keep building our sequence. Anytime you have a number that you're adding or subtracting and that number never changes, then you have an arithmetic sequence. All right. This amount that you're adding or subtracting each time, this is referred to as the common difference. And if you think about it, it's really called the common difference because it's the difference between one term and the term right after it. And it's the difference between them. These terms all differ by 1s, and that's a common difference for all of the terms throughout the sequence. All right, let's just clear this off here and look at an example of a slightly more complicated sequence. So what if I had a sequence maybe that looked maybe like this? Say I started with a 10, and then maybe the next number was 8.5. and the next number was a 7, and so on. Maybe the question is, what's the common difference? And probably you can tell pretty easily, but what's the common difference? Okay, so what's the common difference? Well, think of it this way. Now, if this was a more difficult example, you might want to know that it works like this. 10 plus the common difference, which usually we use the letter D, has to equal the next term in the sequence, which is 8.5. So this is a very easy thing to go and solve. I'm just going to take 10 away from both sides. So the common difference, D, is 8.5 minus 10, or negative 1.5. Okay, so if it were a very complicated series of terms and maybe you couldn't just guess it, it's nice to know that you can just do a little bit of algebra just like this, very simple, and figure out what the common difference is. What I'm now going to do is try and develop a formula. And what we want the formula for is a situation where, let's say, we had a whole bunch of terms in a sequence, and somebody said, I wonder what the 412th term is. Be nice if we had a formula for that. And so this is what I'm doing. So term 1, we're just going to say, very general, has some numeric value A. Term 2 in our sequence, well, that would be A plus the common difference D. All right, now term 3, I'm going to take the previous term, which is A plus D, and I'm going to add another D to it, another common difference. So I could simplify that a little bit, and it would look like this. a plus 2d. Okay, so let's move on, see if we can determine a pattern here. I would take this previous term, which is a plus 2d, and I'm going to add a common difference to that. So what am I going to get? I'm going to get a plus 3d's. All right, so if we were to keep going like this, what would be the nth term in the sequence? Well, if I look at what I got sort of previous as my sort of evidence here, I think I'm going to have a, so I think that's going to be part of it, plus, and I'm going to have a certain number of common differences, and how many common differences? Well, look over here. When it was the fourth term, we had 3 common differences. When it was the third term, we had 2 common differences. So here's what I think, here's how many common differences we have. N take away 1 is how many common differences we have. And guess what? This is the formula for an arithmetic sequence. So be careful that you know your sequence is arithmetic. There are plenty of other sequences that are out there, and we're going to be looking at different ones as we work our way through our knowledge of sequences. So make sure if you're using this formula is for arithmetic sequences. Okay, let's see. I think we're going to do one quick example using the formula, and then we're going to stop with part 1. So here's what the sort of thing we might want to figure out. Somebody says, we've got this little sequence here. Okay, so 2, 6, 10, dot, dot, dot. And we would sure like to know what is the 28th term in this sequence. So here's what I'm going to do. I know that I have this formula here. T sub n equals a plus n minus 1 times the common difference d. And I know I'm looking for the value of the 28th term. What does that right away tell me? It tells me that n is 28. All right, so that's what n is. So we know, okay, over here, that's going to be 28 minus 1. Now, let's have a look. What's our first term, a? Pretty obvious. It's 2. Okay, so that's a. And what seems to be the common difference as we go from term to term? Well, I think it's positive 4. So that's what this is. So all that's really left to do now is to evaluate this. So I'm going to have 2 plus 27 times 4. Well, remember to do your multiplication before you add the 2. So 27 times 4 is, let's see, 108. And so when I add 2 to that, the value of that term is 110. And that's going to be where I'm going to stop for this first look at arithmetic sequences.